Alright, so today we're going to be doing 2-3, which is going to continue with the factoring refresher. So the first thing we're going to talk about today is the AC method. And the purpose of the AC method is it allows us to factor trinomials that have an A term that is not 1. Okay? So here's the steps. I will be going through these steps as we go through the procedure, of course, but if you ever need to reference them, they're going to be here on your notes. So let's talk about how you identify when you need to use this method. So as you can see here, we have a trinomial with an A, B, and C term. You can tell the A term because it is the one with the x squared, the B term is the one with the x, and the C term is the constant. And sometimes you're going to have an A term that is something other than 1. See, the coefficient is something other than 1. And when that happens, the first thing you always want to check for is if there is a GCF. What do you think? Is there a GCF here, yes or no? No. Good, because none of these numbers can be divided by the same number other than 1. So for that reason, we're going to move into the next step, which is the AC method. Now the reason it's called the AC method is because you get rid of the A and you multiply it times the C. Okay? So what's 2 times 18? Good, 36. So that's what's going to go right here. And whatever you get when you do that multiplication is what goes in that spot. Alright? So now once you do that, you're now going to factor it into 2 binomials. And those 2 binomials, we're going to know the numbers from them by finding factors of 36 that add up to negative 15. So can anyone name some factors of 36? 6 and 6, good. 6 times
3 and 12.
Good, 3 and 12. So this one is promising, but 3 plus 12 is actually positive 15, right? So what could be an alternative?
Negative 12 and negative 3.
Good, negative 12 times negative 3 would give me what I need, that negative 15, right? So that's going to be negative 12 and negative 3. Now we're not done yet because we did some multiplication to get this answer, so we need to counteract that multiplication. How do we counteract multiplication in math? Divide. We divide by that original A term, the A term that we used. And if it divides, you're going to just divide it. If it doesn't divide, you're going to have a fraction that may be able to be reduced. Can this fraction be reduced? No. So when it can't, you're just going to bring that denominator in front of the x. And then the other number just stands. And this is what we call the fully factored form. Okay? Fully factored form. Anyone have any questions about that?
Sorry, I just didn't catch that. Why are we dividing by 2?
Because we multiply, it's how the procedure works for AC method. It's like a trick. So to start, we multiply by the 2, and then to counteract the multiplication, we then divide by it. So it's just to reverse what we did earlier. Any other questions? Alright, let's go ahead and try the next one. So the first thing you want to check for is there a GCF? No. So we're ready to proceed with the AC method where we multiply the A and the C together. That's going to give me P squared plus 22P minus 240. Now we're going to be looking for factors of negative 240 that will add up to 22. So this one's a little bit more tricky, but I'm going to divide negative 240 by 30, okay? And when I divide it by 30, that gives me negative 8. What do you notice about 30 and negative 8? What's the product of them?
20.
Good, but what is their sum?
22.
22. Isn't that what we want, right?
Yes.
So for that reason, those are our 2 factors. So large numbers like that can take you a few minutes to get the proper factors. Just take your time. I won't give you one that's way too out of the, your time limit or anything like that, but I will give you some that would require you to take a few minutes to find the factors. And then from here, we're going to then divide by our A term, which is 5. What's 30 divided by 5? Good. And can I reduce 8/5? No. So I bring the 5 in front of the p. And this is the fully factored form. Now when I say it's the fully factored form, what that actually means is if I were to use FOIL to multiply that out, it would end up giving me the original problem. Okay, that's what that means. Alright, do we have any questions before we move into C? Alright. So let's go ahead and try C. So the first thing we check for is there a GCF? No, there is not, so we're going to go ahead and proceed with AC method. N squared plus 5n minus 36. We're looking for factors of what that add up to what?
36 that add up to 5.
Very close. Negative 36 that add up to 5. Good. So anyone have any ideas of factors of negative 36 that would add up to 5?
Negative 9 and 4.
You're so close. Not negative 9 and 4, but
9 and negative.
there we go. Right numbers, opposite signs. There we go. So good job, both of you. So that's going to be a positive 9 and a negative 4. So does everyone understand why we picked the larger number to be positive here? Because this has to be positive. And the sum of two, a negative and a positive, if the larger number is the positive, that number is going to be positive. Okay? So now from here, we're then going to divide by our a term. In this case, both of these fractions can actually be reduced. What would that first fraction actually reduce to?
3.
Good. And what would the second one reduce to?
2/3.
Good job. Once you reduce those fractions, you're going to bring the denominators in front of the n. And that is our fully factored form. Does anyone have any questions about C or need more time on C?
So how do you split it up with the denominators to do this? But that, it's supposed to be a 5, so how do you know which one goes to the 3 and which one goes to the 2?
From here to here?
No, from the last step to like.
Oh. Whatever the denominator is the one that goes in front of the n.
Alright. Right, but how do you tell which one is divided by 2 and which one is divided by 3?
I didn't. I divided them both by 6, which was the a term. You always divide them. I just reduced those fractions. Does that make more sense?
Yeah.
Okay. Yep, you always divide by the same thing. It just so happened they reduced and ended up with different denominators. Alright. So now we're going to do an example where we have to factor out a GCF. Now this is very, very, very important with AC method. If you don't factor out the GCF, your problem is going to have a little bit of an error in it when you go to the next step. It's basically going to leave out whatever that factor is, okay? And that's kind of more complex for the reasoning for that, but basically here you have to look and see, do you have a GCF? What do you think?
Yes.
Yeah.
What is it?
2.
Good. The GCF is actually 2. So once you identify that GCF, you're just going to bring it to the bottom of the problem, and we're just not going to worry about it. It's going to be there at the end, but from here on out, we're just kind of ignoring it for a while. So when I factor out that 2, that means I divide every single term by 2. Okay, that's what factoring out looks like. So I just take every term, and I'm simply dividing it by 2. Is everyone with me on that so far? Okay. Now we can go ahead and proceed with the AC method, which says that we multiply our A and our C together. That's going to leave me with m squared plus 15m minus 100. So we're now looking for factors of 100 that add up to 15.
You mean negative 100?
Good, thank you. Factors of negative 100 that add up to 15. How many nickels are there in $1?
4.
4. What?
Nickels. Not corn.
Nickels.
50?
20, very good. So, positive 20 and negative 5 multiply to give you negative 100 due to their opposite signs, but they would add up to 15. Does everyone see that?
Yeah.
Okay. That's so funny because every class today was like, oh, 4. And I'm like, wait, what? Yeah. So now we're just going to divide by our a term. Remember, you use the a term that you multiplied by, so not the original problem anymore, because we already factored out that 2, okay? So the one that we multiplied by. Very important. What is 20 divided by 4?
5.
Good. And then this fraction cannot be reduced, so we bring the denominator in front of the m. Now our final answer is when we write this next to the 2 that we originally factored out. Are there any questions so far?
Where'd you get the 4 from?
The 4 was because we factored out a 2, which means that we divided every term in this original expression by 2, which would give me 8 divided by 2, which is 4.
And you're going to use that, whatever you multiply that number, the c by, that 8 by 5?
Exactly.
Okay.
Alright, moving on. For letter E, is there a GCF, yes or no? No, no GCF at all. So, when there is no GCF, we can just go ahead and multiply the A and the C. Any ideas for factors of 36 that would add up to negative 12?
Negative 6.
And?
Positive. Wait. Negative 6.
Good. It's...
Sorry.
Oh man, I got a YouTube video running. Okay. So basically they're both gonna be negative, right? So we are then gonna divide by our a term, which in this case is 9, right? And what does 6 over 9 reduce to as a fraction? Good, thank you. 2 over 3. And then what do I do with that denominator?
Put it in front of x.
Good. Put it in front of the x. That gives me 2x minus 3 and 2x minus 3. Now this is an acceptable final answer, but does anyone know another way we could write it?
Get rid of that one and square it.
Good. You can put it to the second power when it's the same. So I just want to make sure you're aware of these two versions of the final answer in case it comes up on a test or anything like that. Either one is acceptable, and either one could be a proper multiple choice answer. Does that make sense?
Will they ever both be on there?
What?
Will they ever both be on there?
No. Not unless they said which are multiple, like it was a multi-select. They couldn't ask you like they are the same thing. So now we're going to talk about how we deal with when the a term is negative. So when this happens, we simply just factor out a negative 1, which means we basically just divide every single term by a negative 1, which is just going to change the sign of every term. And then that negative 1 is just going to sit on the outside of whatever we factored. So here we're just basically changing the sign of every term. That's what happens when we factor out a negative 1. So I'm just rewriting it with all of the signs changed to the opposite sign. Okay? Now once we do that, we're ready to look for a GCF, which we don't have another GCF here. So we just can multiply So, ideas for factors of 8 that add up to negative 9. Good job, negative 8 and negative 1. And it doesn't matter which order you write them in because the commutative property of multiplication. Now what do we need to divide each of these by?
-1.
You always divide them by whatever you multiplied by, which is 2. Good. So I'm going to go over here because I'm running out of room. So that's just going to be 2y minus 1. And then the other one's going to be y minus 4. And then as my final answer, I just write it next to the -1 right here. Anyone have any questions about that? All right. So now we're going to talk about difference of squares. So difference of squares are in the form basically a and c. So it's like a quadratic that just has the a and the c term like that. Okay? So let's talk about how we solve these and how we can understand them. So this is just a quadratic missing the b term. So if you're missing something, what number could you put in its place? Not 1, but one less than 1. 0. So if I want to put something in as what we call a placeholder term, I can put it in as a 0. Okay? So I put in the 0 as a placeholder. And now I want you to factor this as we've been factoring with the 0. Okay, so I just put in the b as a 0 term because it doesn't change the actual equation or expression in any way. So what two factors of -4 will add up to 0?
+2 and -2.
Good. So that's how the difference of squares works. Now let me show you an easier way to deal with difference of squares. What does the word difference mean in math?
Subtraction.
Good. And square is like a perfect square. A perfect square. Can anybody name a number that is a perfect square?
16.
That's one of them. Good.
4.
4. Yeah, there's a bunch of them. Not that, though. So, if we write 2 parentheses here, this is how you always deal with the difference of squares. One's going to be a plus, one's going to be a minus, and you basically take the square root of each of those terms, and that's what goes in those spaces. So what is the square root of x squared? Good. What is the square root of 4? 2. So see, there's 2 different ways of doing the same problem there.
How do you know one's gonna be plus and one's gonna be minus just because it's 0?
Yeah, I was showing you like the reason why it works that way from this problem, but then showing you here you can just go ahead and jump through that step if you want to. Yes.
And that's just if it's a perfect square. If it wasn't a perfect square, it's like 5 or something, you need to do past it.
Yeah, if it's not a perfect square, it's typically not going to factor at all, and it's what we call prime. And we're going to learn more methods of factoring when it's not a perfect square. But yeah, this only works when it is, when both of them are. All right, let's try the next one. What do you think h is going to factor into?
9.
Good, so it's going to be y plus 9 and y minus 9. And if you were to use FOIL to try to get back to the original, you're going to notice that the 2 middle terms actually cancel out, the b term, which is why the b term isn't there. All right, so the next one, letter I. What is the square root of m squared n squared? Mn. And what is the square root of 49? Good. Not too bad, right? Pretty easy? Okay. So now we'll talk about a few more complex versions of these types of problems. Moving down here. So this is what we call hidden difference of perfect square. So Hidden difference of perfect square can come up in several ways. Most commonly it comes up where it looks like it's actually a sum. So everybody see how it looks like it's a sum? So there's two approaches to this. The first approach would be to simply factor out a -1, which is going to change the sign of all terms. And then once you factor out that -1, we now see that it's actually the difference of perfect squares, right? So that's going to be -1, and then we have our parentheses, our two sets of parentheses, a plus and a minus. What is the square root of 9x squared?
3x.
Good. What is the square root of 25y squared?
5y.
Good. So that's the first method. Now the other method would be to rearrange by putting the second term first and the first term second. Now be aware when you rearrange terms in math, whatever sign that number has comes with it when you rearrange, okay? So this is now going to factor into two binomials, positive and a negative. What is the square root of 25y squared?
5y.
Good. And the square root of 9x squared?
3x.
Very good. And these two are what we call equivalent expressions. They mean the same thing, they're just written two different ways. So you could rearrange them so that they matched. It is possible. Alright? So does anyone have any questions about J? Alright, we got two more problems and then you have time for homework. So let's look at K. So for K, the first thing we always want to do in any form of factoring is look for a. Do we have one here? Yes, we have one. What is it? Very good. So we're going to take out that 2. So when I take out the 2, it means I divide by 2. Now we actually have the difference of two perfect squares. What is the square root of 36?
6.
What is the square root of r to the 6th? Anyone know? Thank you.
R to the third.
R to the 3rd. Very good. Because r to the 3rd times r to the 3rd is r to the 2nd. And then what is the square root of s squared?
S.
Just s. And that's the final answer. And the last one we'll talk about today is the often forgotten perfect square of 1. Yes, what's up?
Why do we have two,
Oh, I'm sorry, you're right. Thank you. It's a positive. Thank you for that. Okay, so for the next one, we're going to talk about the perfect square of 1. So, what's the square root of 1? 1. So it is also still a perfect square, okay? So what's the GCF here?
2.
Very good. 2a squared b. We can take out that whole thing because each one has at least one of them. And when you take that out, this first term just becomes a 1 because you took everything out of it. And then it's minus 16a squared because you took out the b and you took away 2 of the a's. Is everyone good with how we got that part? Now this right here is actually the difference of perfect squares, even if you don't see it right off the bat, because 1 is still a perfect square. So we have our plus and our minus. What's the square root of 1?
1.
What's the square root of 16a squared?
4a.
4a. So that one, a lot of people would think they would leave it right here. Bathroom? Yeah, go ahead. Alright, so does anyone have any questions about that? Alright, you have the rest of the period for your homework assignment.